The universe, we once believed, was a grand mechanical clock, predictable, determined, ticking along the iron laws of Newtonian physics. But then came quantum mechanics, revealing a subatomic world where particles dance in ghostly superpositions, where reality itself seems to hesitate until the moment it's observed. As Federico Faggin, the father of the microprocessor, puts it in Silicon, we built computers thinking nature was deterministic. Then quantum physics showed us that at the most fundamental level, reality is built on uncertainty, and that changes everything. This quantum uncertainty isn't just laboratory trivia, it's the crack in determinism's armor. Take the famous double-slit experiment, where particles behave differently when observed. It's as if reality itself is shy, like a character in The Truman Show, suddenly changing behavior when it senses the camera's gaze. Some interpretations, like the von Neumann-Wigner hypothesis, go even further. Consciousness itself may be the force that collapses quantum possibilities into concrete reality. Faggin takes this startling idea and runs with it. In Irreducible, he argues, if my computer were conscious, it would experience itself making choices, but it doesn't, because consciousness isn't computation. There's something irreducible about the way a mind interacts with quantum uncertainty that no algorithm can replicate. This isn't just philosophical musing. Neuroscience is revealing cracks in the deterministic brain model. The famous Libet experiments of the 1980s, often cited as proof that free will is an illusion, showed brain activity preceding conscious decisions by milliseconds. But as Faggin counters, the readiness potential isn't a decision. It's more like a car's engine idling. The key moment isn't when the brain prepares to act, but when consciousness vetoes or endorses that action. That's where true will resides. Modern research supports this view. Studies using fMRI show that while our brains may initiate actions unconsciously, we retain the capacity to consciously override them, like Neo in The Matrix learning to stop bullets midair. The Penrose-Hameroff theory of quantum consciousness takes this further, suggesting that microtubules in brain neurons might exploit quantum effects to generate genuine free will. Quantum entanglement adds another layer to this mystery. When particles become entangled, they instantaneously influence each other across any distance, what Einstein called spooky action at a distance. Faggin suggests our consciousness might similarly transcend the brain's boundaries. If two electrons can communicate faster than light, why couldn't mind extend beyond the skull? The materialist assumption that consciousness is locked inside the head may be the most parochial idea in science. Pop culture keeps circling these ideas. In Doctor Strange, the Ancient One shows Stephen Strange that reality is infinitely malleable to a trained mind. In Westworld, hosts gain true consciousness not through better programming, but by developing quantum reveries. These stories resonate because they hint at a truth materialism can't explain, that we're more than biological robots. The implications are profound. If Faggin is right, then creativity isn't just neural noise, it's consciousness surfing quantum possibilities. Moral responsibility isn't an illusion we truly could have done otherwise. AI will never be truly conscious. It lacks the quantum light of subjective experience. As Faggin concludes in Irreducible, either we're meaningless accidents in a meaningless universe, or we're participants in a cosmic dance of consciousness. The evidence, I believe, points to the latter. This is the quantum revolution of free will, not a return to magical thinking, but an embrace of science's deepest mysteries. In a universe where observation changes reality, where particles communicate instantaneously across light years, perhaps consciousness isn't just a fluke of evolution. Perhaps, as Faggin suggests, it's the key to understanding reality itself. The microprocessor showed me how to build thinking machines, Faggin reflects. Quantum physics showed me why they'll never truly think. In that paradox lies the most exciting frontier in science today, the mystery of how mind meets matter, and what that means for our place in the universe.